All right, welcome to lesson 3.19. Here we're going to continue working to accurately and efficiently sketch the graphs of rational functions. Let's go ahead and get started. All right, so as you remember, we have a really simple plan for sketching the graphs of our rational functions. We're going to look at the key characteristics, the x and y intercepts. We're going to plot those points. Then we're going to look at the vertical asymptotes. We're going to plot those. Find the horizontal asymptote, sketch those out as well. And then finally, we're going to make a quick sign chart to determine what our function is doing in between the roots and the vertical asymptotes, or another discontinuity if I have one. So I want you to go ahead and try executing that for this function here, and then we'll go ahead and take a look at it together. All right, so to start off with, the x-intercept and y-intercept, very easy to find. They actually happen to be the same point. The function intersects the origin. So I'll plot that point there. Now looking to the vertical asymptote, I can see here that an x value of 3 will make my denominator 0. So my vertical asymptote would be the line x equals 3. And I've sketched that here. Next, I want to determine the horizontal asymptote, and I want to look at the leading term. And I notice that the leading term in both numerator and denominator has a degree of 1. So I know that what is going to determine my horizontal asymptote is the relationship between the coefficients. The coefficient here is 2, the coefficient here is 1. So my horizontal asymptote is going to be the line y equals 2 over 1, or y equals 2. And I can sketch that. And it will look just like this. One note here is that even though I'm sketching the horizontal asymptote going all the way through, remember that my function is totally fine to cross the horizontal asymptote, right here in the middle of my graph. But it's only once it gets out to the far left and the far right that I need my function to approach but not actually intersect. So keep that in mind, and don't worry if your graph happens to go through your horizontal asymptote somewhere near your y-axis. Just make sure that it's approaching it as you move out to the left and to the right. Okay. So now at this point, I want to make a quick little sign chart where on my sign chart I'm going to have the root at 0 and the vertical asymptote at 3, and I'm going to determine the sign in between those points and to the left and to the right of them. All right, so here's my sign chart. I'm simply going to evaluate my function at some points in between these intervals to determine what the sign's going to be. So I can pick a nice easy point to the left of 0, for example, -2. And my numerator is going to be negative, my denominator is going to be negative, and so that will make my function positive. In between 0 and 3, I can pick a number like 1. My numerator will be positive, my denominator will be negative, therefore my function is negative. To the right of 3, pick a number like 4. My numerator will be positive, my denominator will be positive, therefore my function is positive. So I can go ahead and make sure I'm going through my x-intercept. It's important to note that this is the only point at which my function will cross the x-axis. So as I'm graphing, I want to take note of that. Let's go ahead and start out to the right here, and notice that my function is going to be positive, so it's going to be above the x-axis here. And as I move out to the right, my function's got to approach my horizontal asymptote, so it will look like that. And as I move towards my vertical asymptote, it's got to approach positive infinity. So it will look like that. In between 0 and 3, I know that my function is going to be negative. So that means leading up to my root, my function is going to be below the x-axis. And as I approach my vertical asymptote, it's going to approach negative infinity. So it will look like that. To the left of my root, I know that my function is positive, so it's above the x-axis, and it's got to approach my horizontal asymptote. So it will look like that. A couple of key things to notice. The way that I'm really going about graphing this is recognizing what my key characteristics tell me. My horizontal asymptotes will tell me what my function does as I move far out to the right and to the left. I know as I approach my vertical asymptotes, I'm either going to be approaching a y value of positive infinity or negative infinity, and I can ascertain that from my sign chart. And I also know that the only point at which I can intersect the x-axis is the point at which I've found my root. And so combining all of those together, I should be able to sketch these pretty efficiently once I've gotten a sufficient practice. So with that being said, let's go ahead and get some practice in. Remember, you can always check the solution, the graph that you get, by graphing your function on Wolfram Alpha. But I want to see all of the key characteristics that you found and your sign chart. So it doesn't make any sense to look at the graph before you've actually sketched it out yourself. All right? Let's go ahead and take a look. All right, here they are. There are 3 functions for you to graph, and then another problem here which actually has you do the reverse. So make sure you've completed all of these problems so we can take a look at them tomorrow.